Hi, I'm Ethan Kwan, and today I'm going to be showing you how to group, not too big, all the numbers. So all the numbers, I'm going to conclude all the numbers using an Euler diagram. So most people call this a Venn diagram. I'm using an Euler diagram. And here are the group of circular thingies. Whatever. Anyway, so I'm going to be using an Euler diagram. Euler was a great mathematician. Definitely should check him out. Just search him up. It's easiest. Anyway, I'm going to conclude all the numbers using an Euler diagram. Wrong way. Okay, anyway. First of all the real numbers. So all the real numbers means stuff like, so I'll zoom in. Ooh, that looks cool. So all the real numbers, like, for example, like 2. Why does it keep doing that? So 2, for example, and 21, or 211, 211, any number like that. You know what I mean. Okay, we're going to zoom out. So these are the real numbers. So these are known as the whole numbers. Whole. Anyway, so let's move on to the next category of numbers. So the next category of numbers, this group, they're known as the rational numbers. The rational numbers are numbers like rational, and the rational numbers are, for example, like 1 over 10 and 22 over 7, or 22 over 1, or stuff like that. So those are the rational numbers. Let's zoom out to the next. Okay, so those are the rational numbers. And here are a big group of numbers. They're known as the constructible numbers. Constructible. And that basically means any number that can be constructed, right? So for example, like 5 and root 2 and root 3 and square root 33, stuff like that. Root 2 billion, 568 million 720. Like that. So these are the constructible numbers. Now, what we're going to do is zoom out to the next group of numbers, which are called, I hope I have enough space for this, because I'm still not even close to the title. Anyway, so the next group of numbers, there are not many there are a bunch of numbers in here. I'm not going to list all of them, but they're known as the algebraic numbers. The algebraic numbers are like cube root of 2 and cube root of 3 and so on like that. Anyway, after that, we have the computable numbers. Computable numbers. Anyway, so these are the computable numbers. So there are not many computable numbers. Computable numbers are like e and pi and e to the pi, or was it the other way? Pi to the e. Anyway, pi to the e, we don't know. Pi to the pi, we don't know. E to the pi, we don't know. Anyway, we also know that those are usually the numbers, like anything that you can have an algorithm to compute. So like cube root of 2 would be also computable, but they're also considered algebraic. So we would just leave them in as algebraic. Okay, anyway, so out here, after that is a C, literally, a sea of weird numbers. They're weird. Out here, there's a sea of weird numbers. Now I'm gonna mess up my nice little drawing, which is sad. And I'm gonna mess up my drawing like this. We're gonna add another section right over here. Sad. Okay, so we're gonna add this Venn diagram looky thingy right here. And you know what? I'm gonna delete that and delete that and delete that, because there are numbers out here. So these are known as the normal numbers. So they go into the constructible numbers, they go into the algebraic numbers, and they go into the computable numbers. So any number that's normal that means like you can find any number, like your phone number, in them. So like, for example, square root of 2 would be normal if you could find anything in it. E would be normal if you could find any number in it. Pi would be normal if you could find any number in it. Cube root 4 would be normal if you could find any number in it. But we haven't proved those things yet. But here's one interesting fact. We have proved that this number, which is known as C, is normal, and that goes into the computable numbers. So C, and it's a decimal thing, so C is equal to, and I've memorized all the digits, 0.123456789101 12, 13, 14, 15, 16, 17, and so on, and so on, and so forth. So, as you can see, you can find any number in this. So it's 0.123456789101112131415161718192021223232342526. One nine zero 191 192 193 194 195 196 197 198 199 200, and it keeps going on like that. Okay, anyway, so that is a number that's normal, and it's also computable. Now, of course, this number, so all the normals are usually uncomputable, the ones outside of the computer. Computable. So actually this normal section should be, so if we redraw it out here, if we redraw it, the whole thing would be about that big. Like everything, like So there's our drawing. So everything in there would be about that size. And our section should be about, here I go, and actually this section should be in there. Anyway, so that's about how big the normal section would be. So, see you. Whew. Excuse me. Anyway, so I would see you at howtodostufwithethan.com and see how big do I need it. See you next time. I like spirals. 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 Whatever. Let's go to. Yay. Whatever. Please go to Let's Have a Chat, even though you can't see it. Whatever. Me. Anyway, see you at howtodostufwithethan.com, and see you next time. As you can see, I'm on howtodostufwithethan.com. Bye.